Okay, so good afternoon. Today we're going to understand what hex is, what it's used for, and how to convert from hex to binary and binary to hex. We're not going to learn how to convert from denary to hex and hex to denary. It is possible, but I always think it's much easier to convert from hex to binary and from binary to hex rather than going straight from denary. So if you have a denary number like 23 or -2, I would always convert that first into binary and then from binary into hexadecimal for two reasons. One, because it's easier, and two, because that's what you'll be expected to do in the exam. You're never expected to go straight from a denary number into hex, which is nice. Okay, are you ready? Copy down this number. You've got 5 seconds. 5, 4, 3, 2. Oh, I counted too slow. Got it. An alternative way of doing this would be to represent the exact same number, but as hexadecimal instead. That means you can have a whole 4 bits in just one character. So say, for example, denary, we have 10 possible digits. 1 to 9 plus 0, there's 10 of them. And we choose that because we've got 10 fingers. It's kind of natural to us. But it doesn't make sense to map that denary to binary. It's wasteful, because by the time we get up to 10, we've got some extra things in our binary that we can't represent in our denary. And when we get beyond 9 up to 10, we have to use an extra character. In hexadecimal, we get around that by saying, well, I don't want to use 10 because that's 1, 0, that's 2 characters. Instead, I'll just say A, B, C, D, E, F. I could have continued on to G, but actually I'm stopping here because I want 16 unique symbols, 0 to 9 and then A to F. Why 16? So using 4 bits, we can represent 16 possible values. That's why we use hex. So how do we convert? Well, let's start with 6C, and then you follow for this one and we'll go through a couple of examples. So first step, you don't need to write anything down yet, is to write down the hexadecimal, 6C, with some space in between them. If they're all numbers, it's dead easy, because the next stage is just write down the number again. If they're letters, it's slightly more confusing, and I know you'll want to do this in your head, but don't, because in an exam you'll be in a rush and you'll get it wrong if you're like most people. So remember, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't need to write that down, but do remember that A is 10, and they keep going up to F, which is 15. Always write this down as the first thing that you see whenever there's an exam question about hex. Otherwise, you'll forget and you'll think F is 16. It's not, it's 15. So C is 12. So we've just converted a letter to a number so far, and a number was already a number. Next, we know that every character in hex is worth how many bits? 4 bits for 6. Well, that's easy. We've got 1, 2, 4, and 8. What do we need to add together to get 6? Well, it's just 4 and 2. So 0, 1, 1, 0 is 6 in binary. And we do exactly the same for 12. So 1, 2, 4, and 8. What do we add together? It's 8 and 4. So if we want to go a single character into binary, then we've just proved that and we've done it twice. If we want to do 2 characters from hex into binary, you just put them next to each other. The binary is just the 2 binary nibbles. A 4-bit is a nibble. It's just that. And if you had 20 of these, it doesn't really matter. It's no more complicated. You just break them up into characters and you do each of the characters as separate 4 bits. And it is actually that simple. Okay, let's do one more example. So we're going to convert E9 this time. First of all, we look up our table. There it is. E is 14. 9 is just 9. 1, 2, 4, 8. 1, 2, 4, 8. So E9 in binary is just that. Okay, that should hopefully be enough. Have I got the worksheet open? So actually, activity 1 is the other way around. We've got binary separated out into 2 nibbles. A nibble is 4 bits. That's 4 bits, it's a nibble. That's 4 bits, that's a nibble. That's 8 bits, that's a byte. We need to do hexadecimal. So if we've got 0, 0, 0, 0, 1, 0, 0, 0, let's write that down. We use our table that you will write down now. And we kind of do the process in reverse. We say, what's this in denary? Well, 1, 2, 4, and 8. It's just 0, isn't it? 1, 2, 4, and 8. Notice this is not 1, 2, 4, 8, 16, 32, 64, 128, or minus 128, or negative. We treat them as separate nibbles. Why? Because a character in hex is 4 bits. So this is just 8. So that in hex is just 8. If that was bigger than 9 and it was 12, we'd have a final step to find out what 12 is, and we'd have to write a letter. But that's all we need so far. I'll do the last one as an example. This one down here is a 2, a 4, and an 8. So that is going to be 8 plus 4 is 12. Add another 2 is 14. I can't write 14, I need to know what that is. So I should remember this here, write it down. E is 14, there we go. So 14 is E. Then I've got this. This is easier because it's just 1, 2, 4, 8. It's just 8. 8 is less than 10, so I can just write it down. Some hex numbers are both numbers, some are both letters, and some are one of each. Activity 2 then is just the same but in the opposite direction. So we've got hexadecimal and we need to work out what the binary is. So 0 in hex is just going to be 0 in binary. 5 in hex is just going to be 5 in binary, which is that because you've got 1 plus 4. It's actually a really concise way of representing binary data. So for activity 3, this video is probably blocked for you, but you've got some code here, including some stuff that we haven't actually learnt yet in Python. And this stuff is brilliant for helping with you. It's all about, don't want to paste that in. Some of the things that we found really confusing and difficult to do with a limited number of lines of code, you can now do with this iteration. So this was an example actually we're doing with A-level at the moment. Stuff in Python they had to convert to C#, and then low-level little man computer stuff in 2 slightly different variations. All this program will do is repeat something 10 times. So for a variable in a range of numbers from 0 up to just before 10, display it. This iteration is what we're going to cover next week and we'll move on to, and is really powerful. And we need that for the code that you've got in your worksheet. So we've got some other stuff we haven't seen before. A turtle is like an animal that can crawl along the floor. You can control this turtle and it will move and it will draw. So we make the turtle and we give it a colour. Notice this is hex. This is hex. Look, it's got some F's, it's got some characters in, it's got some letters as well as some numbers. It's hex. Have a look at these lines. Class charts positive question coming up. What does line 24 to 26 do? So we've identified that we move forwards. We've identified that we have a right angle turn in the right direction. But this bit means we're repeating 4 times. That's the bit that draws the square. So your job is to visit this website which generates hexadecimal colours. This link should work for you. And all of these have the colours in denary, in HSL, which you'll probably only understand if you choose iMedia. I'm not going to explain it today, and hex. So for every colour we are using a byte, a number between 0 and 255, another byte and another byte for the amount of red. So pure red should be all the red switched on, all the green switched off, and all the blue switched off. Pure green is just the amount of green light switched on, and pure blue, wherever it is, will be just that value. So notice 00255 is going to be 0 for red, 0 for green, and FF. We're not writing 255, we're writing it as hex. So if you put in a value, FF, 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 clash. So for the last activity, you've got some code on here you can copy and paste into Create with Code. I need you to choose some of your favorite colors. This is the amount of red in hex, this is the amount of green in hex, this is the amount of blue. So if you've got full-on red light, that makes it quite pinky, with a little bit of green light, that kind of softens it, and quite a lot of blue light, it's quite a light red peachy colour. You need to choose one of your favourite colours and write down what it is in Deanery and what it is in hex. And then also, if you can, get a little screenshot of the colour on here as well.